In this video, I'd like to demonstrate integration between Cloudian and LucidLink distributed file system for the object store. We'll begin by creating a file space. I have a Cloudian environment that has 3 buckets existing. I'm going to grab my credentials and start a file space called Cloudian using the Cloudian endpoint of, I'll use HTTP. So I'll grab my endpoint, HTTP, and my region is US West 1. So after I create the file space, we'll begin to set up the file space global namespace. While that's happening in the background, I'll describe the environment we've got. You've seen that we've got a Cloudian environment with 3 buckets existing within the environment. We have a Linux machine, a Mac OS machine, and a Windows machine that I'm currently running on. I have a small amount of data which I'm going to use to demonstrate the data layout within LucidLink in the object store. So that's a 2 megabyte text file. I've chosen this because it'll showcase our compression. So this is just complete text throughout the whole document. So once we've finished our setting up of the global namespace, we'll be able to initialize the file space. So that initialization process will ask for our credentials from our Cloudian. They will be our access key and secret key. We will then ask for a shared secret, which is going to form the basis of our AES 256 encryption for the file space data layout. So now that our file space is ready to initialize, if I select Initialize, we'll be prompted to download and install the LucidLink OS client. I've already done that on my Windows machine and my Mac and my Linux machine. So I'm ready to paste my access key and get my secret key that I can then paste to complete the initialization with a shared secret of 1, 2, 3, 4, 5. Remember, we stretch that to our AES 256 encryption key and say initialize. You'll then see the tile change from initialize to open. Given that we've initialized through the LucidLink app on our Windows machine, we're already connected. So you see we can open the folder. If we go back to our Cloudian, so our file space is ready in the portal. If we go back to our Cloudian and go back to our buckets, we will see that we will have a new bucket called Cloudian file space, which is the one we just created then. And this bucket will be empty. So at the time that now it's empty, if I go and open my file space, we'll see that we've got an empty file space that, for the purposes of this demo, I'll put a folder in there for the Windows machine we're currently on, put a file in there, and then we will copy our 2 megabyte file to our file space. We'll see that a small amount of data is going up. Remember, this is a 2 megabyte file. So when we look at what the data layout is going to look like within the object store, we will see that that 2 megabytes of data has been compressed to 1, 2, 3, 4, 5, 6, 7, 8, 9 kilobyte objects. So at this point, to showcase our garbage collection, I'd like to delete this file now. It will take 10 minutes for these objects to be garbage collected. So at 5:04 p.m. is when we've deleted the data from the file space. So while we're waiting for that, I'm going to go ahead and join our Mac OS to the same file space called Cloudian with our shared secret of 12345. And on our Mac OS, I'm going to open up, and you'll see that we're going to propagate across the file space the way each individual operating system wants to liaise with the file space universally. So Mac OS has added the dsstore file. If I create a new folder, we'll see untitled folder propagate. If I give that folder a name for Mac OS, we will see it propagate to our Windows machine. And if I perform the same task on my Linux machine by joining to Cloudian file space 12345, we will see the mount point appear, and we'll also be able to add a new folder which will synchronize in metadata and propagate across all the OS clients, and we'll call that one Linux. And as you can see, it synchronizes across. Now equally, if we were to create a new empty document, text document, and call it data.txt, we will see that text file propagate. If we were to open it with LibreOffice, we will see a lock file appear for that text file. If we add some data to it and perform a file save and a close, we'll see the lock file disappear. We will be able to look at that data in Notepad and add something else. And then on our Mac OS machine, we'll be able to open with text editor and we'll see our additional data. So now we've shown 3 operating systems collaborating in the same file space. We've added some data. We've demonstrated our data layout. So if we look at what our objects look like now, we can see in the object store, we have a few objects, 2 pages of objects, not a huge amount of data, but we're expecting some of the original data of 11:03 p.m. to be garbage collected at 5:14. We'll fast forward to so now that it's 5:15 p.m, we'll have a look at our data layout by pressing refresh. We're expecting to see these 9 kilobyte objects from 11:03 disappear because of garbage collection, cleaning up that 2 megabyte file that I put in before. So after a refresh, we see the objects that only comprise of our current data layout. That is the changes that we've made to our file space with the directory structures, with these additional files, and with the data text file that we added some data and something else into it. Now, what we've demonstrated here is native integration between LucidLink and Cloudian. The LucidLink unique block level data layout that enables us to perform random access out of the object store using our metadata synchronization across the clients. We compress the data and able to dramatically reduce the capacity utilization at the object store, along with secure the data by encrypting it at the client side so that the data within the object store is not accessible from anywhere other than the LucidLink OS client on Windows, Mac, and Linux. Thank you.